Okay, now let's continue with our DC machine. Now we have just learned the separately excited DC motor. So now we move on to another type, it's called DC shunt motor. Now in electrical engineering, the word shunt always means parallel. So this is the equivalent circuit of a DC shunt motor. Can you see that our RF, our magnetic circuit, is now a parallel to your armature? Whereas just now in the separately excited DC motor, your RF circuit, the magnetic circuit, was separate circuit. But now this is a parallel circuit. Okay? But the concept or the way to analyze them is the same. Now the characteristic of separately excited DC motor and DC shunt motor are very similar. They are very similar. They are constant speed motor. In other words, the speed don't change much. They are quite constant, which is a good characteristic. Okay? Now let's look at the mathematics. Now there are three currents here. The total current is called the line current. This is called the field current, which we already learned many times. And this is called the armature current because it's passed through the armature. So let us now come up with a relationship between the three currents: line current, field current, and armature current. Right? You learn that line current is equal to field current plus armature current. That is your Kirchhoff's current law, isn't it? This main current come here and split into two. Okay? Now let's calculate IF. IF is equal to VF divided by RF. Am I right? It's the voltage here divided by the resistance. Now this is a parallel circuit. This is 230 volt here. So what is the voltage here? The voltage here is also 230 volt. Okay? So it's therefore equal to Vs divided by Rf. So it's 230 divided by 160 ampere. And if I were to use calculator to calculate out the value, that would be 230 divided by 160. So that is equal to 1.4375 ampere. Okay. So with that, I'm able to calculate the IA. Alright, IA is equal to IL minus IF. And IL is 3.9 minus 1.4375. So I have 2.4625 ampere. So that's the armature current. Alright, so the next thing to calculate would be, if I were to ask you, calculate for me the power developed. It's the same. You would say it's equal to V times I. Which V? EB. Right? EB. And IA. Right? But do we know the value of EB yet? We do not know. We know IA, right? But we do not know EB. So we need to calculate EB. Now, what is the total voltage here in this branch? Again, it's 230 volt, right? That is Vs. Vs. If I know Vs, I know IARA. Am I able to get EB? Yes. 230 volt minus my IARA will give me EB, right? By Kirchhoff's voltage law. So if I go to this working here, EB equal to Vs minus IARA. So that's equal to 230 minus IA is 2.4625 minus 0.3. So that's EB. Okay? So times, okay, I use my calculator. So that is 229.26 volt. Okay, so that's back EMF. Okay, so therefore power developed is equal to EB multiply IA. So that's 229.26 multiplied by 2.4625. So that is 564.56 watt. Okay, so can you see the mathematics is quite similar to separately excited DC motor just now, except that the circuit is a parallel circuit. So we need to do Kirchhoff's current law to find IA, right? And then use KVL to find EB. And then power developed is the same formula, EB times IA. Okay, now then move on. If you were to ask to find the torque developed, formula is 60 divided by 2 pi n multiply power developed. What is n? N is the speed. So if I say that the speed now is going at 620 RPM, right? 620 RPM. Then I'll say this is 60 divided by 2 pi multiply 620 RPM, multiply the power developed. So fine, I use my calculator. So that is equal to 8.695 Newton meters. Okay, so that is the mathematics about shunt motor. Okay, let's now come back to here again. This is a DC shunt motor diagram. DC shunt motor diagram. And if I were to ask you again, as a summary, would you be able to give me a relationship between the three current? Yes. IL equal to IF plus IA. How do I calculate IF? The voltage here divided by the resistance. This is a parallel circuit. This 230 volt. Here is 230 volt. So 230 volt divided by 160 F give you IF. Right? If I know IF, I know I line current. Can I find IA? Can. IA is equal to total current minus IF. How do I calculate EB? The total voltage here is 230 volts. Okay, 230 volt minus IARA. Right? I know IA already. So IA times RA, I get the potential difference across here. So this minus this will give me EB. If I know EB, can I find power developed? Can. Power developed is equal to EB IA. EB IA. Right? Then after that, can I find the torque developed? Can. 60 over 2 pi n multiply power developed. Okay? So that is shunt motor circuits analysis. Thank you.